Good day everyone. In this video, we are going to tackle about the axiomatic structure of mathematical system. Before we go to our discussion, let us first observe this picture. What do you see on this picture? Yes, that's right. You observe shapes, angles, circles, measuring balance. And what branch of mathematics do we cover these topics? Yes, that's correct. These topics are covered in geometry. So in geometry, we have the mathematical system. When we say mathematical system, it is defined as a structure from one or more sets of undefined objects, various concepts which may or may not be defined, and a set of axioms relating these objects and concepts. It is also called an axiomatic system in some reference. There are components of mathematical system, which are the undefined terms, definitions or defined terms, axioms or postulates, and theorems. When we say undefined terms, these are terms that are left undefined in the system. Instead of providing a definition for them, we resort to a description, illustration, or by providing a demonstration on how it came to be. So one of the undefined terms is point. So point, it has no length, width, or thickness. Thus, it has no dimension. It is also represented by a dot. Here is the geometrical representation of the point. Uppercase letters are used to name a point. The name of the point is placed near the dot, above, below, or beside the dot. In the illustration, there are 3 points, namely point S, point K, and point C. Another undefined term is line. Line has no width or thickness but has an indefinite length. It is a set of points that extends indefinitely in opposite directions. There are 3 ways to name a line. First is using a lowercase letter. Based on the illustration, the 2 lines are named as line M and line D. The name of the line is placed near the arrowhead. The second one is using numbers. The 2 lines are named as line 1 and line 2. The name of the line is placed near the arrowhead. The third one is using 2 uppercase letters with a symbol for a line. The symbol for line is a double-headed arrow. To name the line, for example, identify 2 points on the line and place the line symbol above the 2 points. Based on the illustration, here are the possible names of the 2 lines. One line may have a lot of names, but it will still refer to the same line. Another undefined term is plane. It has no thickness but has an indefinite length and width. It is a set of points that extends indefinitely in all directions, and it is a flat surface. Here is the geometrical representation of the plane. A parallelogram or any 4 closed figure is used to illustrate a plane. Uppercase letters are used to name a plane. The name of the plane is written in any corner inside the parallelogram. Based on the illustration, the 2 planes are named plane Z and plane Y. So in geometry, we have a term called collinear points. Collinear points are points that lie on the same line. On the illustration, there are 2 lines, namely line 1 and 2. And there are 7 identified points, which are points O, S, W, U, T, R, and X. So, on the illustration, in line 1, the collinear points are points R, T, S, U. And on the line 2, the collinear points are points O, S, W. There is another term used in geometry, which is coplanar lines. Coplanar lines are lines that are found on the same plane. Look at the illustration at the right. There are two planes, which are plane D and C, and 5 identified lines, which are lines W, V, X, Y, and Z. Are lines W, Y coplanar? Yes, they are coplanar because they belong on the same plane, which is plane D. How about the lines VX? Are they coplanar? Yes, they are coplanar because they belong on the same plane, plane C. How about the lines ZX? Are they coplanar? No, because line Z is on plane D, while line X is on plane C. How about the lines V, Y, and W? Are they coplanar? No, they are not coplanar because line V and Y are on the plane C, while lines Y and W are on plane D. They all should be on the same plane. There is also a term called intersection. When you say intersection, it refers to something that is common to both lines and planes, or it is where the lines and planes meet. On the illustration, what is the intersection of line 1 and 2? The intersection of line 1 and 2 is point S, since it can be found in line 1 and 2. Another component of the mathematical system is definition or defined terms. These are some terms that are defined using the undefined terms. For example, we have angle. Angle is a figure formed by two rays called the sides of the angle, sharing a common endpoint called the vertex of the angle. Another example of a defined term is parallel line. So parallel lines are lines on a plane which do not meet. So this too is considered as defined terms because it has a specific and agreed upon meaning within the context of geometric definitions and principles. Another component of mathematical system is postulates or axioms. These are statements that are considered true even without a proof or validation. Here are some examples of postulates. First one is true and at 2 points there is exactly one line. Second one is if two lines intersect, then they intersect at exactly 1 point. In mathematics, the terms axiom and postulate are often used interchangeably, as they both refer to fundamental assumptions or statements that are accepted without proof within a particular mathematical system. However, axiom is more general and is used in broader context, while postulate is the term often used specifically in geometry. Theorem is another component of mathematical system. Theorems are statements proved to be true using postulates, definitions, and other established theorems and logic. An example of theorem is the vertical angle theorem, which states that vertical angles are equal in measure. So the proof for this theorem is by construction and measuring. There are other statements that we use in geometry, which are proposition is a true statement that needs to be proven. Lemma is a minor theorem that serves as a stepping stone towards the proof of a theorem. And corollary is an established theorem that is used to prove other subsequent propositions.
So here are 5 axioms or basic truths in Euclidean geometry. Number 1, A straight line can be drawn from any one point to any other point. Number 2, a line segment can be extended indefinitely in both directions. Number 3, a circle can be described with a center and radius. 4, all right angles are equal. 5, if a line intersecting two lines forms interior angles less than 90 degrees, then the two lines will intersect on the same side as the angles that are less than 90 degrees. This fifth axiom is also known as the parallel postulate. Properties of a mathematical system. First, consistency. An axiomatic system is said to be consistent if there are no axioms or theorems that contradict each other. Second, independency. A postulate is said to be independent if it cannot be proven through using other axioms in a system. An axiomatic system is said to be independent if all its axioms are independent. All axioms are fundamental truths that do not rely on each other for their existence. Third, completeness. This refers to the statement whatever we attempt to test with the system will either to be proven, it or its negative will be proven. This is somewhat like consistency. For example, if a statement is considered as an axiom, then its negation is not valid. On the other hand, if a statement is not valid, then its negation will be accepted as a truth. That's all. Thank you.